In today's discussion, we will be tackling about Module 2 in Geography 2. This module is entitled Mapping Earth's Surface. Under our discussion content are the following: the definition of cartography, ways of telling the map user what the map is measuring on Earth's surface, explain the concepts of scale, resolution, and projection, how to use this, the scale, resolution, and projection, and other coordinate systems. First, we have the definition of cartography. Cartography is the study, practice, and interpretation of maps. This combines science, aesthetics, and techniques. Due to this combination, it builds on the premise that reality can be modeled in ways that communicate spatial information effectively. Second is the ways of telling the map user what the map is measuring on Earth's surface, and then explain the concepts of scale, resolution, and projection. There are different ways on measuring a map depending on the projection. In this case, we have three projections: conical, planar, and cylindrical. Moreover, these projections use different measurements such as time zones, equal distancing, and aeronautical purposes. Here we have the Lambert Conformal Conic Projection, or LCC. A Lambert Conformal Conic Projection, or LCC, is a conic map projection used for aeronautical charts, portions of the state plane coordinate system, and many national and regional mapping systems. It is one of the 7 projections introduced by Johann Heinrich Lambert in 1772. When we say conic map projection, it is used to map the mid-latitudes or standard parallel. Moreover, it uses great circle to calculate the shortest distance between two locations. Next is the Mercator Projection. This projection is cylindrical. The Mercator projection preserves shape and angle but strongly distorts area in the process. As you can see on the illustration given, Greenland is large because it was distorted using this projection. It is used for navigation, topography, or elevation, and weather maps. Last is the polar planar projection. This type of projection is usually tangent to the globe at one point, but may be secant also. The point of contact may be the North Pole, the South Pole, a point on the equator, or any point in between. This point specifies the aspect and is the focus of the projection. The focus is identified by a central longitude and a central latitude. Possible aspects are polar, equatorial, and oblique. The given illustration is polar. They are used most often to map polar regions. Next is the concepts of scale, resolution, and projection. Map scale measures how much the features of the world are reduced to fit on a map. It shows the proportion of a given distance on a map to the corresponding distance on the ground in the real world. A graphic scale is a ruler printed on the map and is used to convert distances on the map to actual ground distances. One important advantage of graphic scales is that they remain true when maps are shrunk or magnified. Resolution. Resolution is the size of the smallest feature that can be represented in a surface. The accuracy at which the location and shape of map features can be depicted for a given map scale. Projection. Projection is the process of making a two-dimensional map from a three-dimensional globe. This transformation may depend on what purpose is that map. Now, how to use this and other coordinate systems. For scaling and resolution, we have this scale and resolution equivalency. For projection, it depends on what is the purpose of the map. May either be for navigation, aeronautical purposes, or time zones. Latitudes and longitudes in a Cartesian coordinate system, which is latitude represents as x coordinates, while longitudes serve as y coordinates. Together, they can locate a specific area on a map. So this is for today, guys. I hope you learned something. And my name is Ferdinand B. Francisco Jr., BSED SOC Stud 1, and this is my instructor on MCSSE 103. Goodbye!